Hello, and thank you for watching this video. What I would like to talk about in this video is something I call stereotypes, the building blocks for quality code. These are some very simple and easy ways to control the quality of your codebase and consistency across your entire team. I've been using this concept for years to simplify my code. I'm excited to share it with you. Let's dive in. Before we get into talking stereotypes, let's talk first of what your code might look like if you don't have some quality standard. Say a new JavaScript engineer is trying to create a server endpoint. Say in the framework such as Express.js. The engineer will likely Google the framework Express and see what the endpoint is supposed to look like. They might use their basic example as a starting structure and then place all the remaining logic that they need to write into their REST endpoint handler. Sure, they might see some simple abstractions and they might take them. Other developers will then come in and follow the exact same pattern set forth by the original engineer. So you're heavily leaning on the correct application architecture from the get-go for your team to follow. Your project suddenly runs into something that I call code illusion, assuming that all patterns set forth on your codebase are there for a reason. So let's talk about how to fix this and get the code patterns right from day one. So when writing code, you must understand that there are generally three types of code I classify. Those are functional flows, the code that is responsible for triggering a series of steps based off some type of event. There are units, code that is responsible for performing a single focused task. And integration services, code that is responsible for transmitting and or receiving data. So let's look at a scenario. An end user hits your API, that's the event. That event triggers a functional flow. Functionality must occur. The REST API must validate the request by calling a unit, invoke a service to save data, and then format a response to be turned back to the client. In that simple example, there is one event, one functional flow, one API service, and two units. Let's say another engineer wants to come in and modify the REST endpoint to add additional logic. He or she can simply create a new functional flow and attach it to the original one. By doing this, there's minimal interlocking and there's a clear separation of responsibility. And one last scenario. Let's say an asynchronous event must trigger a functional flow. Say you have some type of component in your UI, or perhaps you have a subscription that is listening of events to occur. A service in this case might be responsible for capturing the initial event and passing it into your functional flow. So let's talk different types. For functional flows, we have two overarching types: read actions or write actions, or what I like to call queries and mutations. As I said, queries perform reads of the system, gathering various data to be displayed for a user, or data for perhaps another system. Generally, the party which is interested in the query is the same as who triggered it, which makes these flows fairly simple. Mutations, on the other hand, tend to grow as they are writing to the system. These mutate or modify the original state of the system in the reaction to something happening. This could be saving a new object to a database, writing a message to a topic log, or changing the state of something in memory. Often, more and more parties are interested in when these happen, so they generally tend to grow, as I mentioned. Identifying the functional flow allows other engineers to identify the purpose of the flow, as writes are generally more expensive to the system. Generally, you'll not want to add writes to a query unless they are some sort of analytics or logging action. Alright, let's move on to units. Although there are truly many ways of which you could classify units, I'm going to focus on a single principle, and that is purity. You always want to have as much of your code base as pure as possible. By definition, purity means that your code is stateless, consistent, and has no side effects. The more code that you have that meets these conditions, the better your code is going to be. Now, what makes these good? Well, pure code is 1. Easy to understand, 2. Easy to test, and also 3. Easy to modify. On the other hand, we also have non-pure units. These are the guys that generally create most of the business logic bugs because they manage some state of objects. The code is generally hard to follow because it is bouncing everywhere, and they cause side effects in the system which are difficult to track. So I'm to break units down into 2 types. What I call utility units, which are stateless and synchronous computation. And then there are stateful units, which contain stateful synchronous computation. Note that units should always be synchronous, as the logic should never leave the current process by definition. So you might use your utility units to do object creation, object manipulation, or calculations, whereas your state units might keep track of something in memory. Ideally, you want as few of the state units as possible, as state increases complexity of the system. And the last type of code we have is integration services. Integration services cover all scenarios in which you want to leave the process to do something. Maybe you are going to read data from a database, or maybe you want to read a file off the file system. The point of these is, if you are leaving the process to go do something or receive something, use these as the gateways that manage the connectivity and to simply pass the data and not transform it. Since you can receive or send data externally, we identify integration services into 2 types. Egress services, anything that you are pushing out, such as calling a REST endpoint, or ingress services, anything that you are pulling in, such as a topic subscription. Now the last thing I want to cover is what I had first mentioned at the beginning of the video, the actual stereotypes. Stereotypes are a way of identifying a source code file for what the type of the code that it contains. I'm showing here a sample table of what some of the ways that we discussed that you might identify your code. When tracking types of code with a team, you should create a table like this to denote everything that you're going to support as code in your repository. You can include additional properties like if it is stateful, if it should contain caching, and you can even specify which dependencies you should use in each type of file. That will help guide your team as to where their code should land. Next, I want to quickly show another example of how you might rename or reuse some of those stereotypes for a web application, and how you might test the various components. This table here shows some naming conventions of stereotypes and properties, such as state and component, that I've used in the past and have done wonders for consistency and conformity in large front-end applications. And as you will notice, there are going to be different ways you want to test different portions of your code, which I will cover in a later video. So I'm going to close this video up with just a few architectural concerns that you will want to be aware of when implementing your own stereotypes and building blocks for quality code. Those are performance, scalability, security, and maintainability. From a performance perspective, it is very easy to keep track of specific functional flows or units that might be troublesome from a performance perspective, and you can have focused efforts on improving those identifiable snippets of code. From a scalability perspective, all your code is blocks. If you need to enable your code to scale in some way that it previously could not, all you need to do is reorganize or reshuffle those blocks around those areas that might be blocking or preventing your architecture from scaling. From a security perspective, It is very easy to comment and document who should have access to read and write to each system. When your code is organized to directly provide that information, it becomes incredibly easy to audit the code and validate the rules are being followed. And last, from a maintainability perspective, the code should speak for itself. The organization should be transparent, and what type of code you might find where becomes precise. This is such a game changer for any pull request or code review, as you can exactly identify which type of code should be found where. There's no question about it. It makes pull requests focus on maintainability rather than just pure coding preference. And that's it for the video. If you have any feedback for me, please leave a comment below. Thank you for watching and happy coding!